Live from New York, it's Ask an Engineer.
Hey everybody, and welcome to Ask Engineer. It's me, Ladyada the engineer, with me, Mr. Ladyada on camera control, broadcasting live into your living room, phone, or computer from downtown Manhattan. That's where we do all of that manufacturing and designing and testing and shipping and coding and soldering and videoing and more and more and more. We got a jam-packed show for you tonight. Lots of videos, news, updates, dark modes that you may not have known about. Mr. Ladyada, why don't you tell them what's on tonight's show?
On tonight's show, the code is RTC BAT. That's code 10%.
I love RTC BAT.
Yeah. 10% off an Adafruit store all the way up to 11:59 p.m. Eastern time. Please use it. Ladyada will talk about the free stuff and just a bit that you can get as well, but that's 10% off for you who's watching live. Next, don't forget, we do live shows. We'll talk about show and tell. We had a bunch of folks showing and sharing things. Good, amazing projects. Our favorite half an hour a week every single week. We'll talk about from Disc of Ladyada, including the Great Search, highlight from JP's workshop, some Made in New York City factory footage, some 3D printing. We got INPI this week. It's Microchip brought to you by DigiKey. We've got some top secret. We got new products. We answer your questions. We do that on Discord. Adafruit.it/Discord. Go there, ask your questions. We answer them throughout the show, unless we're multitasking, and then we just save them to the end. But we also do all the questions at the end too. So ask your questions, all your engineering things. You can even post your projects and stuff like that. We have all sorts of things going on. All that and more on, you guessed it, Ask an Engineer.
Yay!
Okay, so codes RTC BAT, Ladyada, there's free stuff. What does it get?
Free stuff. We still have lots of freebies. We're doing so good. I can't believe we can get parts, and now we have the freebies in stock for a very long time. $99 or more, you'll get this beautiful PCB coaster in Adafruit black with a gold logo and edging on it. Comes with 4 bumpers to protect your desk, so you can put your cold or hot drinks on it. I use mine every day. It's wonderful. $149 or more, you get a free KB2040 featuring the RP2040 chip. This Pro Micro Pinout microcontroller board has USB Type-C, Stomach UT, buttons, NeoPixel, built-in memory, castellated pads. You can use it for all sorts of microcontroller projects because it runs Arduino and CircuitPython and MicroPython. $199 or more, you get free UPS ground shipping in the continental United States. It's trackable, it's insured, it's unionized, it's brown, it's UPS. And $299 or more, we have Circuit Playground Expresses in stock. Our favorite all-in-one dev board with the SAMD21 has 10 NeoPixels, 2 buttons, a switch, a buzzer, a partridge in a pear tree, infrared, accelerometers, 8 made to milking, 10 capacitive pads, solid, runs Arduino, code.org CS discoveries, MicroPython, CircuitPython, MakeCode. It's like one of the most universally supported chips. So it's a great all-in-one dev board to get started learning microcontrollers and programming.
Okie dokie. And then I wanted to just take care of some AdaBox news. I'll probably end up linking to this video. So if you're watching this, this was part of our live show, but it's also our AdaBox announcement. So as we said, we wanted to get AdaBox restarted. There was no parts on planet Earth. We have thousands and thousands and thousands of AdaBox subscribers. We don't charge until we ship. However, the part shortage was going on for a very long time. For the AdaBoxes that we do, there could be hundreds of different components and none of them all available at the same time. So we said, well, we'll just keep doing AdaBox. If people say never want to subscribe, they can cancel their subscription. Again, we don't charge until we ship. But But we're almost ready to ship a very small number, and this is a super small number, and it's going to be to some of the first subscribers of AdaBox that have been with us from the very start. I'm going to reach out to them. I'm going to say, hey, make sure your payment information is updated and your address is updated. It'll be coming from an at Adafruit email address, of course, because there's tons of scams out there. And we'll be reaching out to folks before the end of the year. And then what we're going to do is, as we get this first batch out, we're going to start batching out more and more and more, and then get caught up on AdaBox 21. So it's happening. And I don't expect everyone to be nice or kind or patient, because they don't live in a world that they have to get thousands of different parts. They're just like, where's my thing? I just want my thing. So I get it. So I'm gonna just have the team escalate any folks that are not nice to me. But for the most part, most folks are, because I think they understand. If you're someone who keeps track of things with Adafruit, we've had our part shortage segment that we were doing each week or so. We talk about our AdaBox status. So we're getting really close. It's happening. And then next week, full swing. And then we have some more surprise and stuff. So it'll take us a while to get that machine running again, but we're doing it. So expect more. This is the video for that. And let the team know they can expect us to send out some emails, but also want to make sure that the folks that are subscribed, I'm not going to be able to tell you like, where are you at in the queue. There's a very small number we're getting out like right now.
We just have to
Turn this machine
re-enable
on.
the machinery,
Yeah.
and like it's been a while, so things have changed, and like
There's a lot of stuff going on.
yeah.
So, anyways, between COVID and then the part shortage that happened afterwards, and just like kind of planet Earth having lots of issues. Planet Earth's going through a thing right now. The people on it too. So expect it. It'll happen. Thank you for your patience. We don't give up. It's just slog, slog, slog. Wake up, eat glass, keep going. So that's what we're doing. Okay, so that's the update. Live, we do a bunch of live shows. All right, we did show and tell just a few moments ago. Show and tell every week. We do show and tell. Yeah, everybody's nice, by the way. Thank you.
You're all nice.
Yeah. It is because we tell everyone, it's like, here's what's going on. There's no surprise. Like, this is what it is.
mean, post like Raspberry Pi 4, like we are a little like scar tissue now.
Well,
we're covering like
you know
like
what?
the burns are slowly like
Just
slowing.
Before we just go into show and tell, here's one thing I'll say. So often we make hard decisions transparently and smart in front of everyone. An example was Raspberry Pi 5. We said, okay,
4
Raspberry Pi 5
and 5,
yeah,
both.
So Raspberry Pi 5, the words that were used out there was place your pre-orders. And we said, we're not doing pre-orders because that's just going to be a back order. That's going to take forever. So we'll just put them in the store when we have them. We'll notify people that signed up. And if it happens to be on our live show, which we've done, people can order them as we put them in the store live. And we also have two-factor authentication. We did all this stuff. So, there was like really mean people, and they were like opening up Better Business Bureau complaints. I should be able to buy anything I want in back order, and
calling
me on the phone, showing up at Adafruit, stupid threats that, I don't think they're real, but there's like, I'm going to kick your ass, or whatever. So, anyways, we put Raspberry Pi stock in, and I see the responses. People are like, I'm going to cancel my pre-orders elsewhere because I was able to get one from Adafruit. So, I get it. Like, it's a different world where I think you're not rewarded for being nice and reasonable. The extremes are what's rewarded. So just even today, we put Raspberry Pi in stock. Everyone was able to get 5 zeros. And I saw folks say, cool, I'm able to get this before my pre-order from October. And from whatever other sites. So this is happening. It's just like sometimes you just have to make hard decisions and be transparent and be like, here's what we're doing and here's why. And some folks are going to like it, but some folks will. And we show and share our work. That's what we do. So speaking of, on show and tell, we had a bunch of folks who showed up. Jay showed some really neat robot ears that kind of move around. Makes a very cute robot. Pedro showed the LCD fireplace. We're going to show that. JP showed this very neat editor's little helper type thing with it. Corey Doctorow, we know him, had this horn that he wanted to be able to have this horn over IoT go off at his editor's residence, because sometimes you need to get a hold of him. Then you had JP had this music project. We'll show some of the
It's a reverse oscilloscope.
yeah. Aaron had a wireless controllable sign. Gary had a Mandalorian prop. It was one of the things to cosplay with. BCG had a cool keyboard project, and Delchi showed us the Pi 4 touchscreen system, aka it was a view into the Matrix. Check it out. A little bit of highlights and more from the setup that Delchi has, and then all the rest of the show and tells that we had just a half an hour ago. It's on all the places you can watch video now. Stop by every week, 7:30 p.m. Eastern Time, and show and share your project. Okay, Ladyada, on Sundays we do Disco Ladyada. There's two parts. What did you show this week?
Okay. So first off, I showed, I was working on that code for Noah and Pedro to do their LED signs. So I showed playing fast MJPEGs on the Qualia ESP32S3, so that's that part. I showed off the Memento camera, which we have, an enclosure LED front panel that's going to be going to the store. Just put in the camera part this week, but if you watch This Ladyada, you get a preview of everything that's going to be in the shop weeks beforehand. If you're like, what's coming out next? That's where you would go to look. And then finally, I showed off a design that Timon and I are working on for the ADV 7611 HDMI to TTL converter.
Okay. We also do the Great Search. This is where you use the powers of engineering to help people find things on digikey.com. Ladyada, what was the Great Search this week?
Okay, so this week, first off, DigiWish is happening, and they give away free stuff once a day. Somebody from social media, I think it's like Twitter, Facebook, Instagram. If you tag using DigiWish, and you say, "Hey, my DigiWish is this product, and it's $99 or less," you may get chosen to get a free thing. I haven't won because I'm not eligible, but many other people I know have. And then we had a request for industrial micro SD cards for single board computers that are going to be outside, that need to run for a very long time. They're doing 24/7 video recording. So we talked about some of the industrial micro SD cards and how to tell whether why would you spend more money on an industrial micro SD card, and some of the specifications that you can get guaranteed when you go with one of these, not just a SanDisk or a Kingston card, but like a real industrial use micro SD card.
All right. And then, of course, there's JP's product pick of the week. This is a show that we do every single week. It's a segment, and discounts automatically applied in the product page. You just look at the thing you want as JP's talking about it and add it to your cart. And that's it. Discounts automatically applied. Here is this week's highlight.
It is the Qualia ESP32S3. It's an RGB 666 TFT driving board and microcontroller dev board all in one. I've got the Qualia ESP32S3. It is plugged into a little micro SD card reader and then one of these beautiful little rectangular displays. You can see I have video playing on there. It's running about 12 frames a second, and it's just a few seconds long. I'm just looping it back and forth to make a cool little Dieter Rams Braun clock-inspired clock. This has Wi-Fi built in, so this is using, I think once an hour it goes to the Adafruit I/O to grab the time off of the time server and keep itself pretty accurate. It is the Qualia ESP32S3 TFT driver board for RGB 666 displays.
Okay, don't forget JP's workshop is tomorrow, and then on Friday it'll be Scott or Tim for a deep dive. That's where you can dive into the innards of Circuit Python. And speaking of, we got a special treat for y'all this week for Python on Hardware. It's something that would normally be part of our top secret segment, but it's not. It's going to be part of this segment. So first up, I have to remind everyone, please go to Adafruit Daily. It's a completely separate website that has nothing to do with your shopping account. We do not spam. We do not remarket. We don't even use tracking on the sites we don't need to. We do for our, we have Google Analytics on our store, but we're trying to un-Googlify and untrackify anything we can where we don't need something. We don't use that information, so why store it? Why track people? For Adafruit Daily, you can sign up anytime, cancel. This is, I think, the only consistent Python on Hardware newsletter. We have thousands of subscribers. Do check it out. We have a bunch of news. Evan was hinting at an RP2040 successor, a new PyCompute module. These are all things that you're going to run Python on. You can see some interesting things going on with the Python Software Foundation is like, hey, what do you mean open source authors might be liable for code and stuff like that? So they don't like that. You can check that out, the news stories. And then all the things that you expect, like projects that use CircuitPython and RP2040 and Raspberry Pi. You can check out the CircuitPython show, highlights who's on the show next, and then what things that we're doing with Playground, which is our place where people can post stuff. Tons and tons and tons and tons and tons and tons of
Lots
projects.
of projects.
Yeah, but this week we're going to do something a little different. I'm going to ask Ladyada to show off. This normally would be top secret, but this is kind of a big deal for us. This is a completely Python powered digital camera.
Oh, hold on. User interface.
Yeah.
Let me get rid of it. How do I get rid of the interface? There you go. Sorry.
So this is our Python powered digital camera.
Yeah. Okay. Sorry. So this is, I'm going to remove this. This is a battery. But this is a camera that uses CircuitPython and it like acts like a digital camera, like what was that camera you had? QuickTake? It's better than QuickTake though. It's 5 megapixels. So it's got a 5 megapixel.
A completely open source Python camera. I think the first and only.
Yeah. It's got the OV5640, which we've been selling for a bit. This one has autofocus mode. You have micro SD cards for storage. You can connect hardware, analog or digital input, or I2C. It's got an ESP32S3 and it's got great CircuitPython support and also has hardware support for communicating with these cameras. There's a little spot here for the battery, and the battery just sits nicely on top. On the back here, I have the protecting case on it, but there's 4 up, down, left, right buttons, OK and select, a little piezo. This is the shutter button. There's also a reset button and a hardware on off switch. And when it turns on, you'll see it boots into CircuitPython. And then this is the SD card won't be loose on the final versions because I'm debugging and stuff. But you can see it's taking a photo of the what's underneath. And what's cool is that this has autofocus mode. So let's see if I can get it to, yeah. So you saw like it'll be able to take close-up pictures of stuff. And then there's also going to be a LED ring light. And the idea is that, you'll be able to do a lot of stuff. Like, people have open firmware for their cameras. But if you want to write your own like image filtering, or you want to like make a little GIF camera or a JPEG camera, or you want to have something that connects to Wi-Fi or Bluetooth that you can control and you don't have to go through like some third-party website, this is a Wi-Fi capable chip. And so it can send data, like it can SMS you an image or upload it to Adafruit IO, or it can take commands from the internet over Bluetooth. So I think it'll be kind of neat to have like fully open source, like true open source firmware camera that you can code up yourself.
Yeah, and for the folks out there that are like, well, I really want to own my electronics. I want to know what metadata is being put on photos. Well, I don't think there's another thing that comes close. You could build it yourself. You can upgrade it. You can do all the things. I think because cameras are so good, you got to go the other direction.
Yeah. And this has
Make something kind of retro.
hold on, let me see. It can do some modes. So this is gonna come through. So this is inverted mode. Hold on. It's very bright.
The screen's bright.
Yes, this is like inverted.
Yeah. Make your own filters. You could do all sorts of neat stuff.
Black and white mode for like oh, you know what? I didn't have the latest firmware. There's a dither mode that just got added. So like a Game Boy camera, like sepia tones, and then using Microlab, which is like NumPy, you can add your own filters if desired.
Yeah.
So it's like you can have like your Instagram filter style.
So, one thing that I'll say about things like this is I don't know how we're going to teach the next generation of product designers to make things without stuff like this, because everyone's kind of growing up with like, here's a 30 megapixel camera in my phone. Someone has to learn how to make these things, and it's not just going to be like Apple and Google forever. It's a good idea to understand how these things are made and teach other people to do it. So this is like part of that curriculum or journey where it's like you learn how to make your own keyboard, you learn how to make your own blinking LED thing. Then you learn how to. We're gonna have a cell phone, Python powered cell phone at some point. You learn how to make your own Python powered digital camera. So all this stuff that you'd be able to build on your own and understand it. It's not going to be the thing that you shoot your vacation photos on, but maybe. But it is the thing that you're going to be able to.
Cool, like retro,
Yeah.
like Holga-esque, like again, like a Apple Quick Take stuff.
Yeah, this isn't to use as a USB camera.
You can actually, what's interesting, you can have it act as a Wi-Fi camera, but
Yeah.
USB, it actually doesn't have, you need to have USB high speed to do like a true webcam, but you
one
can
day-
transfer data across. It
Yeah.
just isn't like, it doesn't show, we tried to have it show up, but you can have it act as a VNC, I think, and then you can have it appear on your computer.
And then one day, of course, as chips evolve and stuff like that, we tend to have a platform. This will be like the Memento platform for cameras, open source cameras.
Oh, so somebody asked about half press for shutter. So we couldn't afford to get like a custom half press button, but if you hold down, it autofocuses. So long press is autofocus and short press is snap.
Yeah. And,
but you can change that, right? It's like you can record it however you want.
So I think this just kind of fills, again, one of the boxes. You can kind of make your own computer that's Python powered. We've had projects like that. You can make your own keyboard that's Python powered. Now, what about your own digital camera that's Python powered? Mm-hmm. So we think this would be a neat thing for schools, for just about everyone who's looking to say, here's the fundamentals of what a digital camera is. You can teach theory, like here's photons, here's how they, go inside of a chip, and here's how they make the image work. So we think this will be kind of cool to explore. And we'll say hello.
Hi.
Okay. That is our Python on hardware this week, Ladyada.
Snap.
Delivered each week in your mailbox. Python hardware. Beep, beep. All on Adafruit Daily. Okay, let's do some open source hardware news and more. We're an open source hardware company. We have thousands of guides and more. What's on the big board at learn.adafruit.com this week?
Okay, so this week, Melissa wrote a guide that for like basically if people remember like the PyPortal or Matrix Portal libraries that make it easy to interface with displays. She wrote a version for the Qualia board. So if you have one of these like round or square or bar displays and you want to create interfaces quickly, or you want to like port PyPortal code over, check that out. It's called Simplifying Circuit Python Qualia Projects. Of course, we've got the Qualia Fireplace. It's a video playback with MJPEG. Also, Melissa's been updating this Qualia guide for all like the bar displays that are the square displays. As we're putting them in the store, she's getting them and adding code to make sure that it's documented. We've got the Edgelit Tavern sign from Erin. That's going to be. Do you have a video for that? We're going to talk about that in a bit.
Yeah, we're going to show the splash video and also a video that we now have.
Did we do a video last week?
No, well, we have two videos that we're going to show this week.
No, but did we do a show last week or no?
Mm-hmm. Yeah.
We did. Oh, the week before.
Yeah, we did. Okay. We're going to do the splash bar video and then also Trevor's video from the airplane project.
Yes, that was down there. There you go.
The SH project. Yeah.
Okay.
Okay. Do you want to talk about it anymore or can I do the videos?
No, I think the rest of them are from last week.
Okay, I'm going to play the videos back to back, see you on the other side.
Let's figure out where that flight is going with a CircuitPython project. I made this simple flight tracker that shows flights above my home. To power this project, I'm using a Matrix Portal S3, which can connect to the internet and display text on a Matrix display. I'm using two 64x64 Matrix displays, jumper wires, a 2x8 ICD plug connector, and I'm also using a USB-C to connect my Matrix Portal to my computer. To start off, I'll attach the jumper wires to the screw terminals by connecting the red wire to V5 and the black wire to ground. After making sure the arrows on the display is pointing to my right, I'll connect my Matrix Portal to my Matrix display. Then I'll connect both displays to the IDC connector. Now I'll connect my Matrix Portal to my computer. Here I'm using FlightAware's Aero API to get the information that I need.
After a bit of light coding, let's run our project.
Now you can hang your flight tracker next to your window, and if you see a plane going by, you can see where it came from and where it's going.
Have you ever wished to bring the warm glow of an artisanal tavern sign into your living space? You've come to the right place. This tutorial will lead you through building, coding, and wiring your own glowing tavern sign. We make it easy by using the powerful Feather ESP32 and the versatile WLED software, which makes it easy to add animations and control them over Wi-Fi or with an infrared remote. Head over to learn.adafruit.com and embark on your journey to craft your masterpiece. Thanks for watching, and remember to subscribe for more inspiration.
And here's some factory footage. And that's vector footage. Okay, let's do some 3D printing. We're gonna keep this rolling because we wanted to catch up with some videos too this week. So we're gonna play the 3D printing videos back to back. This is a quality screen and also a speed up.
You can build a miniature fireplace that plays holiday-themed video clips using an Adafruit quality ESP32S3 and a rectangular bar display. This festive project houses the Qualia ESP32S3 dev board and a 3.2-inch rectangular bar display in a 3D printed fireplace. It uses the ESP32's optimized JPEG decoding capabilities to play motion JPEG videos stored on a micro SD card. With built-in Cap Touch, you can tap on the display to cycle through different videos. Buttons on the back side of the case gives you access to the Qualia's built-in switches. The micro SD card breakout is accessible on the backside of the case, and the fireplace mantle is swappable, making this a modular enclosure design. You can double-click the reset button to launch the tiny UF2 bootloader and drag over a ready-to-go UF2 file, or compile and customize the Arduino code yourself. The micro SD card is formatted using the standard FAT32 file system. Just create a new videos directory and drag and drop your videos. The Convert.io website works great to convert videos to the MJPEG video format. Higher quality will make for larger files, but they look better on the display. You can get up to 10 frames per second. JPEGs will look best with live action or intricate images, not as good for cell animations. Widescreen videos work best when resizing and rotating to portrait. You can tweak the settings here for the best playback performance. The enclosure parts can be 3D printed using PLA filament without any support material. You can get the parts to build this project, links are in the Adafruit Learn Guide. An 8-pin cable makes it easy to connect the micro SD card breakout to the Qualia ESP32S3. The micro SD card breakout is secured to the enclosure's back cover using machine screws. The rectangular bar display fits inside the case and stays in place with the help of a PCB mounting plate. With the qualia placed on top, the bar display's ribbon cable fits perfectly into the 40-pin connector. The qualia is secured to the mount using additional machine screws. The cover snap fits onto the case, making a nice and neat little package. We hope this inspires you to make your own mini video player with Adafruit's Qualia ESP32S3 and bar displays.
Okie dokie, we're going to go to INMPI in a sec. RTC, that is the code. Don't forget, that's for folks watching. All that free stuff is part of it too, as you add stuff to your cart. Okay, Ladyada, let's do it. All right, thank you so much, DigiKey. This week's INMPI is Microchip Ladyada. What is INMPI this week?
Okay, this week's INPI is from Microchip. Weirdly, coincidentally, I actually this showed up on the digikey.com/new featured product list, and I had a breakout board designed for this. So now that it's back in stock, I was like, oh, I can talk about this chip, and also I know a lot about it because I already wrote a library and code for it. So this week we're talking about the Microchip MCP 3421. It is an ADC, a single channel differential ADC with up to 18 bits of resolution, which is a lot of bits. Most ADCs that people have on microcontrollers are 8-bit, 10-bit, 12, maybe 14 if you're lucky. So 18 is quite a lot. 18 basically means you can start doing very small measurements on the microvolt scale. What I like about this ADC is, it's straightforward. It's got a single channel differential. It's got that 18-bit. It uses I2C, so it's very easy to interface. It's got a couple settings, so you can change 12, 14, 16-bit resolution, which also will change the data rate because it uses a sigma delta analog input. It's got a built-in voltage reference, so you don't have to have like an external, AREF generator, add to your bill of materials and size. It's all built in. It's got a built-in oscillator. It's got built-in gain, so up to 8 times gain. And it's like really simple to use. It's just like a SOT 23.6. So let's take a look at it. So you see at the bottom left, this chip, by the way, it's I2C and it has a fixed address. You can see there's no address pin. But there's variants that come, different variant ordering codes that come with different addresses. I think I have a diagram later of that. Differential input, powered from 2.7 to 5.5 volts. The internal reference is 2.048 volts. So your signal has to be within that range and it's differential, but as long as both the positive and negative are between ground and 2 volts, you'll be able to read the differential signal in. So it's a sine data, and then just I2C for configuring and reading back. Just uses delta sigma. So, one of the things about delta sigma is you can basically add as many stages as you want. So, you can do 8-bit, which is fairly fast. Then, every bit you add doubles the amount of time it takes because you have another stage. So the trade-off with having delta sigma is it's not very fast. I think when you go to 18 bits, it's like 3, 4, maybe 5 samples per second. So this isn't when you're wanting to measure, potentiometer or an analog audio signal. This is good for sensors like pressure sensors, strain gauges, thermocouples, anything that needs high precision, but you don't need very fast reading. Okay, so here you go. So at 18 bits, you're going to get 16 microvolts per LSB. But then on top of that, you can have a gain inside. There's a programmable gain of up to 8. But still, even when you multiply by 8, remember it has to be less than 2.48 volts. And the output, which it gives you, will be between negative, whatever number of bits divided by 2 to positive. So you can connect the negative pin to ground if you want, if you have a single-ended output. But again, it's designed for stuff like thermocouples and Wheatstone bridges where you want a differential input. And here's an example of some wiring. So Wheatstone bridges are used, again, pressure sensors, strain gauges, there's a couple of GSRs, I think, also use Wheatstone bridges. Whenever you have to measure a small change in resistance, this is kind of what it's set up to do. And, if you need, I think for some strain gauges, if the change is very, very small, you might want to add a op amp at the bottom. You can see there the MCP 6V01. I think it's an auto zeroing precision op amp. So that will be good if you have a measurement that's you're going to go below that 16 microvolts per LSB measurement limit. So the demo that I've got is, because I looked at the data sheet, it's like, you can just hook up a thermocouple directly. You don't need anything else. They show an MCP 9800, but that's just because you want to get the ambient temperature to compare against. So because the thermocouple has the change in temperature from ambient. So you use the ambient to then calculate what the absolute temperature is. If you go to the overhead, I'll do the demo now. So I've got, so this is the, okay, so this is the breakout board here that I designed. So you can see the chip over here, and I just have it connected up to, I've got like some capacitors, pull-up resistors, little ferrite bead, and then this is the differential input, and then I've wired the differential input here to a K-type thermocouple, and then you can see this is the ADC reading. I'm just picking this up, and then when I breathe on it, gets warmer, and you can see the ADC picks it up even only a couple degrees. The micro voltage can be with 8 times gain and 18-bit resolution. It's good enough. You can actually measure a thermocouple and get a couple degrees precision out of it directly. No preamplifier, no signal conditioning at all. So a very simple and easy to wire up analog digital converter. Okay, so let's go back. We were just showing off the thermocouple. Wait, can you go back? Is it the yeah, okay. So then yeah, we're gonna do the next one. Sorry. So this is the PCB design. Since it's just an image. Again, the bill of materials is small. I just have bulk capacitor, 0.1 microfarad capacitor, a ferrite, and then a couple of 10K pull-ups. But honestly, probably most of these items you're already going to have on your board. So really, all you end up needing is just that SOT 23.6. Because again, it can run from 2.7 to 5 volts. You don't even need a regulator for it. And then to write a library, I just wanted to write one very quickly. I just loaded up the datasheet into ChatGPT-4, and microchip datasheets are so good that it was like, yeah, no problem. Here's the library.
And as always, the
link is into the chat.
When we use these tools, we link, disclose, we put it in any code, we link to the actual chat that you can see where Ladyada typed in stuff, and a lot of the code is trained on Ladyada stuff, not all of it for things like this. So I think we're encouraging others to do that, and I want to just mention can you do that?
Yeah. So, what I like about Microchip is the data sheets are so good that they're very easy to parse by a chatbot, and it was able to kind of pipe out the library. And then, there's a couple typos and so, but I fixed it up and published it on GitHub. So if you want to get started with this chip really quickly, I have a full Arduino library that sets the gain and the resolution and displays it on this TFT or displays it in the serial port. It also calculates your samples per second. And then yes, if you want to, the default I2C address is 0x68, but if you want, there are a couple different variants, and DigiKey does stock them. So if you want multiple ones on one I2C port, or use an address conflict, check the ordering code, because they're not going to be compatible. On the other hand, if you want to make sure that your system doesn't, your design doesn't get affected by part shortages, just make sure that your code is looking for any of the 8 addresses that you could get, depending on which version you place on your PCB.
And kind of interesting.
Dark mode.
Not only is it in stock, but DigiKey looks like they rolled out dark mode.
Dark mode.
Maybe they just did it for you, but everyone should check and see.
Love it. I mean, you know what? I'm gonna take it. So in dark mode, in stock, all the options are available. This chip is about $2. I found it very easy to get started with. Order it, and you can have it in your hand by tomorrow.
All right, and then there's a short video that Microchip has. We're gonna just play a little snippet from it, and then we'll see you on the other side.
Chip's MCP3421 weight scale demo board was designed to demonstrate the MCP3421 ADC's performance in such an application. It uses the PIC18F4550 microcontroller for data processing and USB communication with a PC. This board also demonstrates the differences in system performance by adjusting the parameters of the sensor signal conditioning circuits by means of Microchip's MCP6V07 auto-zeroed operational amplifier. The MCP3421 Delta Sigma ADC can detect an input signal level as low as 2 microvolts. When measuring such a low input signal level, a low noise operational amplifier is used. The MCP6V07 auto-zeroed operational amplifier has input offset voltage correction for very low offset and offset drift, which makes it ideal for boosting small signal levels. Various signal conditioning schemes can be tested, providing the user an idea of how best to achieve the design requirements. Additionally, you can connect your own load cell for evaluation. In LCD displays the user selection option, ADC output code, and weight. Buttons beside the LCD allows user control. The S4 button is used for offset calibration, S3 adjusts the signal conditioning gain settings, S2 is used to change the information displayed on the LCD, and S5 resets the demo. A LabVIEW graphical user interface allows gain calibration, shows weight, standard deviation, ADC code, and other data to allow system.
Okay, before getting new products, it's RTC BAT. Don't forget that's the code, 10% off in the Adafruit store. Let's kick it.
New.
Okay.
RTC BAT. I kind of like, you can't tell how big is this? Is this like 5 feet across or like a quarter of an inch? This is it's actually about half an inch across.
So it's a trampoline. You could take the red path or the black path, and it's a pool filled with milk.
Yeah, this is an RTC battery for the Raspberry Pi 5, which has built-in low power and wake up support. But to take advantage of that, you need to get a RTC battery, and this is the one recommended by the Raspberry Pi Foundation. Now in stock, I don't know how much documentation there is about the low power mode, but you might as well get one now, have it shipped to you, and by the time it's documented, you'll be ready to rock. This is a revision for the Adafruit speaker bonnet. We finally have these back in stock, and the revision is now it comes fully assembled. So not only is the bottom header on, but the terminal blocks are pre-attached too. So if you want to attach speakers, you don't have to do any soldering whatsoever. This is completely plug and play with any Raspberry Pi computer.
Okay, next up.
Next up, we also have a revision for the FTDI Friend. It's like an ancient product, but still a lot of people buy it. The big change went from mini USB to micro USB. Not a big change, but I figured, you might as well get with the times, even though it's USB Type-C is kind of becoming more popular. But we didn't want to redo too much of the PCB design, so we just swapped out the mini for the micro USB. Otherwise, it's still fully assembled, comes with a genuine FT232RL chip. You can know it, you can trust it, you love it, used in so much stuff. And on the back, there's some jumpers to configure it. Go to the last photo with the coin. You can set 5-volt or 3-volt power and signal logic level. And you can have pin 6B DTR so that you can use it with some software that uses DTR, or use RTS.
Next up.
Next up, oh, we have another screen. This one is a nice round 2.8 inch 480 by 480 display. It's an RGB 666, which means, as usual, it's used with our Qualia board, which we've been doing so many projects with. I've got a live demo for this. It does not have a touchscreen, but we'll probably get a touchscreen version later. So I have it here hooked up to the Qualia, and we've got that video playback code. So
Yeah, I made round doom.
hold on, this is crashing. Hold on, I think the oh, you know what? The cables are loose here. Hold on, cables are no longer loose. Playing Doom or just like an animated
Bill Nye the Science
I don't know
Guy.
why you sent me that gift to play. This one's nice.
It's funny.
This one is just a nice butterfly.
It's a nice butterfly.
Nice butterfly. So these beautiful displays are IPS, so they look great from any angle. Nice backlight, 480 by 480 pixels. You know,
There's a Stargate too in there somewhere.
yeah, hold on, let me get to the. I think these cables are.
Your cables are loose?
Well, I don't know what it is. Hold on. Works great on my desk, but
that's the little, that's cool.
there you go. Nah, Stargate.
Okay, here we go.
Thank
Here we
you.
go. Here
I
we
know
go.
you're always looking. You're always like, "Where's the Stargate?"
Yeah, this is it for the folks who want to make a pocket Stargate. You can't
Stargate.
you can't send an entire person, but you can send
You could send like a mouse.
some baby some body parts.
Yeah, like your fingers, like
Yeah.
through. That's just playing animation, but yeah, it works great with the Qualia board. Just watch out, not every driver or microcontroller can control these displays because it's a lot of pixels, you need a lot of memory, and you have to drive them very quickly. But the Qualia does work with Arduino and CircuitPython, so a great pairing.
Okay. And star of the show tonight, besides you, Ladyada, our customers, our staff, our community, everyone who makes the things go, is, you guessed it, the Pi camera are coming soon. We'll have them in the store shortly. Sign up. These are going to go super duper 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 fast, but this is our camera.
Yeah, the PCBs just came in on Monday, so we're you know, I'm going to finish the tester, but I wanted to get these photographed so that folks could sign up. So this is an all-in-one camera that can run CircuitPython or Arduino. It has an ESP32S3, which is Wi-Fi and Bluetooth capable. 8 megabytes of flash, 2 megabytes of PS RAM, which it needs because it has to read up to 5 megapixel images from the onboard camera sensor. And the camera sensor is in the middle there. It's an OV5640, which is kind of the nicest camera that you can get from microcontrollers at that size. And it's got autofocus capability. So you can take either close-up or far-away photos, and you can manually change the focus or autofocus. It will use the motor to move the lens back and forth for you. You can power it over USB Type-C or battery. If you want battery powered, it'll auto recharge. There's a micro SD card slot for storing images, and you can also take GIFs, animated GIFs. There's Stemma QT and Stemma non-QT ports, 2 GPIOs, analog or digital for LEDs or sensors, and I2C for any other kind of sensor device you want to attach. There's a built-in accelerometer. There's a shutter button, a reset button, an on-off switch so you can save power, a preview screen, 240 by 240 so you can see what the camera sees, lots of buttons, and a speaker that'll buzz when you take a photo or you want to give people signals or something. So I thought I could just show a quick demo of the CircuitPython code running, as you can see the REPL, and it loads the firmware for the autofocus, which takes a few seconds. And then you've got, your own camera here. Let me back this off because this is okay. So, yeah, you got a camera, and you can autofocus, take photos. You can change. This is the firmware that we've got running on it that is in CircuitPython, which of course means you can modify it. This is like black and white mode, like sepia and color modes. This is solarized, like a cool kind of like a funky effect. Normal, inverted, so it's hard to see because it's but it inverts all the colors. You can do JPEG mode, and we have a mode that you can take very small animated GIFs if you want to make an animated GIF camera. Stop motion photography, which is kind of neat. Stop motion means that, let me go back to normal. When you take a photo, it'll show a ghost of the previous image. So if you're doing stop motion animation, you can tell how much you have to
onion skinning.
Yeah, it's onion skinning. This is your idea. It's kind of cool. And then let's see.
Yeah, you can see where the last photo that you took was, so you can do the next one.
Yeah, SD card support.
Good for claymation little videos.
Yeah, we might show a little like how to do stop motion, but like if you want your very own completely open source camera that you can write code for
Yeah.
in Arduino or CircuitPython, and of course it has like web access and Bluetooth access, so you can do wireless projects with it. There'll also be a case. This is showing one half of the case, and then of course I left the other half. There's another half of the case on top that has an LED ring built into it. But for now, we're just having the bare board. If you want to just get started. You want to make your own enclosure, and then we'll also have a case available.
That's new products.
Step, step. New, 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 new.
Okay, sign up for those. It'll go fast. We're going to do top secret, and then we're going to do some questions. You can load them up in adafruit.it/discord or discord.gg/adafruit. Go there and put your questions in. Let's do some top secret.
Top secret.
Okay, zip, 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 zip. We're gonna play 2 videos back to back, and then we'll hit the questions. Ladyada, what's this?
I'm writing some code up for a demo that Noe and Pedro are going to do for their next 3D Hangouts project. This is a SD card connected up with SDIO, so it's got 4 data lines rather than the normal SPI, one direction at a time data, so much faster data reading. And then I'm running this SIMD JPEG decoder on this display from the ESP32S3, and I'm getting like really nice high quality MJPEG decoding with this quality 2 and about 10 frames a second. And then they wanted me to add a thing where when you touch it, it goes to the next animation. So this is just a little fire animation. But at 10 frames a second, you're not seeing as much of the tearing that we had earlier. So I guess there's like some sort of built-in hardware support for JPEG decoding. It looks really good. So this is going to be a guide soon from Noe and Pedro.
Ladyada, what is this?
This is a Grove feather wing. So this is the Seed Grove standard, which uses this kind of like funky connector. And there's like hundreds of Grove sensors available. They tend to use an analog input, but some use 2 digital, some use I2C. This OLED here uses the I2C connection. So there's 3 analog ports, 1 UART port, and 2 I2C. So this one has just running the SSD 1306 library. And then here I have a Grove rotary encoder, and I just have some code that is upside down that's reading it using a CircuitPython running Feather M4. So, I also added a STEMMA-QT port at the end. I had just enough space for a little vertical one. So you can see here the markings that this is like RxTX, 2 I2C, this is A0, A1, A2, A3, A4, A4, A5. So this prototype is working and going to be in the shop soon. Great for getting your existing Grove stuff working with Feather.
That's top secret. Okay, questions. We got some lined up. We're going to do it.
Ask.
Ready?
Yes.
Ladyada?
Hit me.
Okay, so the first question was earlier in the chat is, do you know how many pounds of solder does a selective solder machine go through in a year if we were using it a lot?
I mean, it's a lot, like easily 100, but they come in like sticks of 5 pounds, and you have to the pot itself, I think it's like 100 pounds or something. It's like or whatever, 20 pounds. You have to have a lot in the pot, but it goes quite a bit.
Yeah, the other thing, over time, selective solder isn't as needed for a lot of things because there's surface mount components for a lot of stuff too.
Yeah.
So changes over time. Next up, is it possible to turn this is product ID 1958, to use STEMMA-QT instead of wiring it up manually? In other words, plug and play connectors.
This one hasn't been revised to STEMMA-QT because that chip has actually, I think, been discontinued. So we have to revise the design to use a different chip. So when we do the revision, I'll have STEMMA-QT, but it doesn't make sense to revise something if it's going to be, eventually discontinued real soon.
Okay, can you mix I2C sensor types on a single bus?
Yes, as long as they have different I2C addresses each one. So you just have to look up on the back or look on the data sheet and make sure that there's no conflict.
Okay. From one of the other chats, someone had some pretty specific Arduino IDE questions, and I pointed them over to the Arduino forums. Arduino makes and maintains the Arduino IDE if you're having problems with some specifics in it, I don't even think it was one of our boards. I think it
Yeah.
was a Nano or something. Arduino has a new revamped forum.
Yes.
Do check it out. They have a pretty robust community over there. They also have a Discord that you can check out as well. Some comments that came in chat earlier. Yes, thank you for noticing the onion skinning thing. That is an excellent way to get, especially young people, started up on stop motion, including claymation and things like that. I often think about how do we get the next generation of youngins to be able to do stuff, and a lot of filmmakers and a lot of people got their start doing stop motion, where maybe it was a manual process, then digital cameras came along, and now a lot of things are in computers, but there's still an art of doing stop motion. So
Yeah.
you can check that out. Someone wanted to know, is it better to go into the field? This is career advice. Go into the field right away after their graduation, or do work while they're working? Like, what did you do any engineering work?
I mean, I did summer, right? Like a lot of people do summer internships. I think that's really good.
But
I-
hey,
I would always
if
say,
Adafruit does, by the way, when we do internships, we pay people. This is something that came up a bunch of times because, like, it's in the news. Sometimes there's these unpaid internships. I think they should pay people.
yeah,
Yeah.
I think you know, my personal philosophy is, other than a PhD, you should probably just try to get all your education done early, because it's really hard to go back. You can, people do, but it's just like, once you're on a roll and you're younger and you're like, okay, I don't have as many obligations.
Overhead.
You know, you can get the education, and then you can decide to job hop and try internships and try different companies, and then, you know, explore and try different things. You're not stuck with something. I think it's get harder as you get older.
Okay, next question. This might be the last one. I think we got to all of them. Do Hall effect sensors measure magnetic strength, or just say if a magnet is present?
Hall effect sensors themselves, like the Hall effect, can measure strength, but often when people talk about a Hall effect sensor, it's a not Schottky, it's Schmidt triggered, so it's only telling you if it's present or not.
Okay. Someone in one of the other chats is asking what the discount code is. I just put it in the chat. It's RTC BAT.
Yeah.
Here. Oop.
That's good.
And that's our questions for tonight.
Good. We'll get finished exactly on time.
Exactly on time.
Perfect.
Okay, everybody, thanks so much for joining us this week. Send a special thanks to Zay behind the scenes at Adafruit, doing some stuff to keep the show going. Also, everyone in the chats and in the community, thanks for keeping this open source hardware company afloat and going. We very much appreciate your orders and more. It's the best way to support an open source hardware manufacturer in New York City, and all the things we do, like sponsoring open hardware engineers, open source engineers, and more to do all this stuff. We very much appreciate it. This has been an Adafruit production. We will see you next week. Here is your moment of Xeno.
Bye, everybody.